Hello all. Welcome to Knowledge Share channel. It gives me a great pleasure. Of today, I am going to present about the next OpAMP circuit, that is clamper. Anyway, before that, I will just give you a short introduction of what is a wave shaping circuit. As you all know, that is wave shaping circuit is nothing but it is an electronic circuit in which we get the desired output shape from any input waveform. So that is called as a wave shaping circuit. Already it has been discussed in the previous video, and there are two functions for this wave shaping circuit. The first one is to attenuate the applied wave. That is, attenuate means I have to cut the applied wave, and that particular circuit is called as clipper. The next one is alter the level of applied wave, and that is called as clamper. That is, we want to shift, we want to shift the without altering the shape of the wave. I am just going to shift the DC level of the applied wave. So that is called as clamper. So I'm sure that you have already watched the previous video on clipper, and now we will discuss about clamper. So as in the previous video where we have discussed, like, clipper is having two different types, that is positive clipper and negative clipper. Similarly, clamper will also be having two different types. One is the positive clamper and next one is a negative clamper. So if I am going to shift the waveform in positive direction, then that is called as a positive clamper. If I am going to shift the wave shape in the negative direction, then that is called as a negative clamper. So again, I will just give a small introduction. A clamper is an electronic circuit that produces the output which is similar to the input but with the DC level shift. So that is called as OpAMP clamper. So here we are going to design the clamper using the OpAMP circuit. It has various applications in many of the electronic gadgets. So here I am going to design a clamper using the OpAMP circuit. So here you can see that the input voltage peak to peak and the output voltage peak to peak are equal. Okay, there is no change in input voltage peak to peak, whereas in previous case for the clipper there is a change, in input voltage and output voltage peak to peak values, but by here it is same. So as already discussed, there are two types. One is the positive clamper, the other one is the negative clamper. So how this positive clamper works? So before going to the working, let us discuss about the circuit. So here this is a circuit diagram of this. So here it is having a capacitor and one resistor R1 and one more resistance R2 and one diode D1. So here we are giving the reference voltage Vref through this R2. So I can vary this reference voltage by varying this resistance R2. So here you can see that this is the input signal, and I am going to get the output signal phase that is shifted in positive direction by the amount of the reference value which I give as the input to the plus VCC. Is it okay? So I hope you are all clear with the circuit diagram as well as the input. So input and output waveform remains the same, only the DC level shift is there. So going to the working, so the input voltage, that is the sinusoidal voltage, is given to the inverting terminal through C1 and R1, that is one capacitor and one R1, and similarly the Vref is given to the non-inverting terminal of the OpAMP. So the Vref is can be varied by varying the R2 value, and here the Vref is given as a positive value. That's very important. So if we give the positive value, the that is, it will be shifting in the positive direction, that is, it will be shifting upwards. So the positive clamper, the output is nothing but it is equal to the input plus DC value, and similarly V0 will be equal to that is Vi sine plus V reference. So both will be added and that will be given as the output. So the positive clamper produces the output such that the sine wave is shifted upwards by V reference, that is DC value. So hope you're all clear with the working. Okay. So here you can see that so this is how. So if I just vary the V reference value according to the input value of the DC input value, I can vary the shift of this sinusoidal waveform in upward direction. So if it is if the Vref value is very less, the shift will be very less. If the Vref value is very high, it can be shifted to a very large amount. So this is called as the positive clamper. So next we will discuss about the negative clamper. So in case of negative clamper, as I've already told, it is similar to the positive clamper. The only difference is, so here you will be having a that is the waveform will be shifted in downward direction. So that is called as negative clamp. Okay. So clamping means we are going to shift up or down. So by using this negative clamper, I can shift down. So here you can see there is not much difference. Only differences you can see that see here in case of positive clamper, the diode is in this direction, whereas in case of the negative clamper, the diode is in the opposite direction, and also we are going to give the negative voltage reference input. That is the only difference, and you can see that the input sinusoidal wave shape has been shifted in below 0, that is it is having the negative value. So according to the magnitude of the V reference value, we can shift the sinusoidal input voltage downwards. When the V reference value is very high, you can see that the shift in the sinusoidal input voltage will be very high. So this is the working, and this is the output waveform. Input waveform and output waveform has been given, and this is the circuit. So here the working of circuit is given by, so the sine waveform is given in the inverting terminal through C1 and R1, and similarly the Vref is given to the non-inverting terminal of the op-amp. So the Vref can be varied by varying the R2 value. So the V reference is negative. So this is the most important thing. So the V reference has to be negative. The diode also has to be interchanged. So in case of negative clamper, that is the input minus DC value will be there. The output will be equal to input minus DC value. So similarly, V0 will be equal to Vi sine minus Vref DC. So the negative clamper produces the output such that the V sine, that is the input sine wave, is shifted downwards by V reference, that is the DC voltage which we are giving as the input. So hope you're all clear with the working and operation, and you can see the input and output waveforms as well as the circuit diagram. Okay. So thank you for watching this video. And I'm sure you all would have benefited from this video, understanding the concept of clamper, which is a very important electronic circuit in present world. So thanks for your watching, and please like, comment and share, as well subscribe to the channel if you really like the content which I post to this channel. So thank you very much. Thank you.